So hey guys, welcome back to another lecture. So in our previous lecture we have seen these covariance, correlations and a lot more. So today we're going to discuss these distributions. So this is one of my favorite topic to discuss. So the distribution means like it's just a way of something is shared out among the group. We like, so if we have a 10 biscuits, 10 cookies out there, and then we're gonna share this, we're gonna distribute this to the 10 people, right? So this is a distribution. So in that distribution we have a lot of, in this probability and the statistics we have a lot of distributions out there. So we're going to cover each and everything. So at first we have a uniform distribution. So what do you mean by this uniform distribution? So the probabilities are constant here. So it is, by the word you can understand, it is uniform. This is a uniform. If it is not, then a line it gonna look like this. If it is uniform, then it will be straight, right? So this is a uniform, means like it constant, it is constant, it is not changing, or a possible values of x. So like if the probability a less than or equal to x less than or equal to b, means like if the x, it means like the x lies on the between the a and b. It is not the less than a and the greater than b, it is lies between the a and b, right? So we are saying the constant. So what do you mean by that constant? Means like it does not change when x changes. When x changes, it does not change, it remains same here, right? So then what is uniform? Means like uniform means it remains same in all cases. As I said, now this is a line. If it is moving, then we cannot say this is a uniform, right? I have given a beautiful diagram here. So this is a uniform distribution. This is uniform distribution, and we have a a b c d over there, and this is a rectangle, right? This is a rectangle. How are we going to find the length of that area of that rectangle? L into b, length into breadth. So we're going to find these, like we have a x over there, and we have a, if it is b and a, how are we going to find this b minus a, right? So we're going to simply multiply these. So we want to find that function, so we just simply do the f of x, which is equal to the 1 minus a, 1 by b minus a, right? This is a function, right? So like the probability distribution function, which is pdf of the uniform distribution. So like what will be the pdf, what will be the pdf of this uniform distribution? So like the probability of that function, probability distribution function, is equal to 1 by b minus a for a less than or equal to d, right? cd, we have cd, right? So like we have cd. So these are equal to 1 minus ba, 1 minus ba, 1 minus ba, 1 minus ba. So all these means like all these points are 1 minus ba, all are uniform here. These are not like this, right? So all are uniform here, right? Otherwise it will be 0, otherwise it will be 0 or 1 minus ba. If it is range between this c, this range between this, other than, over than or less than this, then it will be simply 0. Otherwise this is equal to the 1 minus ba, 1 minus b minus a, right? So the median, which is a plus b by 2, and the mean, which is c plus d by 2, mean and the median, right? So if the points are crossed, means like if the points are reached, if the points are crossed, means like if we have this, if the points are less than or a or greater than b, then they simply become 0. The probability 1 means like the probability 1, which means like they are between these two, they are between these two, a and b, right? So like I just wanted to give a practical example. So if a is equal to 200 and b is equal to 250, so what will be the f of x? So we have formula, right? F of x is equal to 1 minus ba. We simply substitute these values here, and we're going to get a 150, 1 by 50, 1 by 50, right? So this is equal to, if 1, it is 1 by 50 when the value, when the x is between these 200 and 250, otherwise it will be 0. Means like if the probability of 290, it will be 0, or it is less than 200, then if 190 or 180, it will be 0. It has to be between 200 and 250, right? So like what we going to do is, so we just simply take this uniform distribution and we simply plot this, means like it's a range from 200 to 250, right? So this is a range. So we just simply plot the uniform distribution. If the p greater than 230, so this is a This is the thing, right? So the probability is constant here. So the probability is constant here until this. It is always 1 by 50 here until this range. If it is below this, then it will be 0. It is above 250, it will be 0. So the probability of x is 150 until this point, from the 200 to the 250. So if, for example, if the probability x is greater than 230, so like we are changing this to 200 to 230 some point here. So the probability will change like here. So the line will be here 230, and this is the our probability now. So the 250 minus 230 into 1 by 50, which is 0.4. So we just simply move 0.4 points here. I hope you understand this. I hope you understand this. So uniform distribution means like what? The probabilities are constant over all the time, over all these values of x, right? So after that we have a normal distribution. So what do you mean by this normal distribution? So it is a symmetric about the mean, showing that the mean are the more frequent to occur from the mean. Means like this is a symmetric, which means like if you place a mirror here, then these both sides will be equal. These both sides will be equal. So that is a symmetric. So if we have mean here, and this is will be the mode, and this is will be the median. If these three are at a same point, then we simply say that distribution is a normal distribution, and then we simply call that curve, which is this curve, as a bell curve, right? So there are many cases in which the data tends to around like a central value with no bias and left and right. There are many cases out there. It tells the probability of occurring the data near to the mean is more than that of the far from the mean. I hope you understand this. So we can say that our data is normally distributed. We can say our data is normally distributed, right? So there are three kind of rules. So it's a three kind of rules, like, so if these are satisfied, then we can say our data is normally distributed. So the mean, mode and median should be equal. Means like they has to be at a same point, same line, right? So after that we have a symmetric about the curve. Symmetric means like we have said na, this this means like if you place a mirror here, the both should match here. And we have 50% values are less than and the mean, and the 50% are greater than mean. So like it is the middle point, right? So this is a 50%, and this will be the 50%, right? So these are the three kind of rules to satisfy, assumptions to satisfy this data before the normal distribution, if you have to accept the normal distribution. Okay, so all the normal distribution can be divided into two parts. They are the mean and the standard deviation. We have discussed the mean and we have discussed the standard deviation. So if you don't remember those, so I just request to please rewatch those lectures. Okay, so I just give means like the mean is the location of that parameter, and the standard deviation is the scaling parameter, right? So I hope you understand this. So I just want you to rewatch and then come back. So the mean is just a location of that parameter, and the standard deviation is just a scaling parameter. So I just wanted to give a geometric intuition, otherwise it will be hard for you. Okay, so like at the geometric intuition, the normal distribution with different means. So how the distribution look like if we have a different means? The distribution look like this. If we have a three different means, then the distribution gonna look like this, having three different means here. So like how the graph gonna look if we have a three different standard deviations, right? So the standard deviations, if we have a three different standard deviations, our data look like this is a standard deviation, right? So please ignore these lines. I'm so bad at drawing, I have to learn this. Okay, so these are the standard deviation 1, standard deviation 2. So I hope you remember those lectures, right? These are the 1 standard deviation, 2 standard deviation, etc. Okay, so I hope you understand this, what is this normal distribution. So like by the word you can understand normal distribution means like it is normally distributed, which is symmetric, right? Where mean, mode and median are at the same place. So after that we have an empirical rule. So what do you mean by this empirical rule? It tells where the most of the values or the data lies at a normal distribution. We have seen this normal distribution, right? So we have seen this normal distribution, and the empirical rule tells the where the most of the data lies in that normal distribution. So how we gonna find that? So like around 68% of the data in within the one standard deviation from the mean. So like this is a mean, right? This is a mean. This is the mean, right? So like this is means like around the 68% of the data in which one standard deviation from the mean. So like this is a one standard deviation. The yellow line is the one standard deviation. Around the 95% of the data, which is the two standard deviation, and the 98% of the data, which is the three standard deviation. I hope you understand this. This is a three standard deviation, this is a two standard deviation, and this is a one standard deviation. Here 68% of the here 68% of the data here, and here, which is a I'll change the color. Here the I'll change the color. So here it is almost 95% of that, and this is almost like 98%. I hope you understand this. I hope you understand this, right? So I just give the notes to the students. It has to be neat. So this is a one standard deviation, this is a two standard deviation, and this is a three standard deviation. Okay, I hope you understand this. And we have a formula for that. How we gonna find that? And we have a formula for that. F of x is 1 by divided by the sigma 2 pi, and the e to the power minus x minus mu square by 2 sigma square. I don't suggest to remember this formula. We're going to, if we use that, and we just simply Google that, and we just simply implement in our code. Okay. So like what is this? Mu is a mean, and x are the values, and this sigma is a standard deviation. We have seen from the two or three lectures this standard deviation, mean, and more, right? So if the mu is equal to mu and the standard deviation 1, then we simply call it as a standard normal. If these, then we simply call it as a standard normal distribution. So what do you mean by this standardizing? We do the standardizing methods by the Z scores, and what are those Z scores, and we're going to cover in the ML lectures. So this standardization is called as a normalization in the machine learning. We're gonna normalize, so we use in the pre-processing module. Okay, so Z score. So how we gonna find that Z score, which is these values minus mu divided by this standard deviation. This is a standard score, right? So it converts the normal distribution into standard distribution, where mu is equal to 0 and the standard deviation is 1. Standard normal distribution. I hope you understand this, right? So after that we have a geometric distribution. So what is this geometric distribution? Which is, so it uses to describe how many trials it teaches to success. It describes like how many trials we have to do to reach the success, right? So if the probability of the success at one trial, which is p, and the probability of the failure, which is 1 minus p, then the probability of the finding for the first success in the nth trial is given by this. So 1 minus p whole to the power of n minus 1 into p into probability, right? So I just wanted to give a example so that it will be easy for you. Okay, so for example, the number of trials is 3 and the probability is 0.4, and we're gonna find the geometrical distribution out here. So we have a formula right here, right? So we just simply plug in these values, x and probability values here. This is n. Okay, so this x will be the x, right? So this is the number of values, these are the number of observations. Okay, so x is equal to 3, then it will become 1 minus 0.4 to the power of 3 minus 1 and 0.4 into 0.4, which is equal to the 0.114, right? So we have find this. So the sigma square, which is 1 minus p by p square, and the sigma, which is standard deviation, is the mu is 1 by p, right? So where the mu and the expected value are the same, On average it takes 1 by p to get the success under the geometric distribution, right? So here the mu and the expected value are the same. This mu and the expected value are the same. On average it takes you 1 by p to get the success under the geometric distribution. I hope you understand this. So if the probability of success is high, if the probability of success, the probability of success is high, you don't have to wait until for a long time to success. And if the probability of the failure is high, then you should stop this. I hope you understand this. So like high means like the probability of the success. If it is 90%, and then we simply do 1 by p, which is 0.9, then it is 1.11. This is a trials on average. And if the probability is low, means like if the probability of that failure or the probability of success, which is 0.1, which is equal to the 1 by p, which is 1 by the probability of that success, which is 0.1, and then we simply do the trial 10. Means like if we do the trials, then it will definitely gonna try 1.1 times. And if we trial these two, and there is a chance of 90% here, the 90% chance to get that, and there is only 10% chance to get here. I hope you understand this. So after that we have a binomial distribution. So what do you mean by this binomial distribution? So a distribution where only two outcomes are possible, such as a success or failure. Binomial, by the word you can understand, bi means two. Okay, so a distribution where only two outcomes are possible, such as success or failure, gain or loss, yes or no, where the probability of success and the failure is the same for all trials, is called as a binomial distribution. So all possible, such as success and failure. Here the number of success is fixed in the number of trials. If we have 100 trials, and with these the number of trials, the number of success is fixed for this number of trials, right? If we run these experiment 100 times, and we can say like a 50 true, 50 success, or 60 success, right? So it summarizes the likelihood that a value will take one or two independent, it will take the one or two independent values under a given set of parameters or assumptions, one or two independent values under a given set of parameters. So we have a small formula over there, which is px. We just simply call this as a number of combination, the combination of n and x, where the p to the power of x and the q, which is the, so this is the probability of the success, and this is the probability of the failure, which is q. The q is also written as 1 minus p. The q is also written as 1 minus p. So you can write this q, you can write this as a this, you can also write this as a this. Okay, so this is a equation of that binomial distribution. So the p is a binomial probability, and the n and the x is a number of combination of that from the n and x, and we have a probability of that x, which is a probability of the success and the probability of the failure, and we have a n, which is a number of trials we're gonna do that, right? So in that binomial distribution we have a properties out there. So we have some kind of properties. So there are two possible outcomes, which is true or false, or which is true or false, gain or loss, positive or negative, success or failure, etc. There must be two possible outcomes. There are n number of independent trials and fixed number of n repeated trials. So the probability of the success and the failure remains same for each trial, for the each trial. Okay, so only the number of success is calculated out the n independent trials. So each trial is an independent trial, so this is a basic intuition about this binomial distribution. So I just want you to research on your own. Okay, so it will give a better sense to you. After that we have a Bernoulli distribution. So I'm so hard to pronounce this name. Okay, Bernoulli distribution. This is a discrete probability distribution. Discrete means what? Independent, right? It is a discrete probability distribution. So it has only two possible outcomes, either success or failure, If it is yes or no, we have given this, we have given a beautiful graph out there. So this is a yes or no. We can say like the single failure or success experiment is called as a Bernoulli distribution, and the sequence of those outcomes we just simply called as a Bernoulli process. I hope you understand this. This is a simple. So I just want you to research on your own. Okay, So I just want you to research on your own, so it will be easy for you. So that is not a big task for you. Okay, so after that we have Poisson distribution. So after the what is this Poisson distribution means, like, so it is applicable in situations where events occur at random points of the time and space, wherein our interest lies only in the number of occurrences of a event. Means, like, it is applicable in situations where events occur. It is applicable in situations where events occur at a random points of the time and space, and where in our interest lies only in the number of occurrences of that event. I hope you understand this. So they are valid assumptions out there. So any successful event should not influence the outcome of another successful event. So if the one event is successful, then it should not influence the another successful event. I hope you understand this. So the probability of the success over a short interval must equal to the probability of the success which is long interval. So the probability of the success in a short interval, if in a short interval of time, it must be equal to the probability of the success in the long interval of time. Okay, so the probability of the success, if the probability of the success interval approaches zero as the interval becomes smaller. Okay, so this is a small geometric intuition about this Poisson distribution. Okay, so we have a lambda over there, which is 1, lambda is equal to 4, and the lambda is equal to 10. So we have a three kind of distributions out there. These are the Poisson distributions. Will give the intuition about the data. Okay, so after that we have a skewness. So what do you mean by this skewness? Means, like, it refers to a distribution of symmetry that derivates from this bell curve, that derivates from this bell curve, or a bell curve, or a normal distribution in a set of the data. If the curve is shifted towards the right or towards the left, then we say it is skewed. So in this example, it is right skewed here. This we simply say that it is right skewed, and if we data like this, then we simply square that is a left skewed here. Okay, I hope you understand this. What is this skewness? So we're gonna see in our machine learning lectures. You don't have to worry. So based on what is this skewness and how we're gonna use this. Okay, so after that we have a Bayes theorem, and this is the last topic in this final lecture. So it is used to revise previously calculated probabilities based on the new information. So it is used to revise the previously calculated probabilities, right? So it is revising the previously calculated probabilities based on the new information. Okay, so it is an extension of this conditional probability. So we're gonna use this Bayes theorem in our machine learning projects, like a spam or ham or credit card fraud detection. Means, like, it is legit or fraud, etc. We're going to use those. So we're going to have a great detailed talk out there. So I just wanted to give a example, like, if the probability, how we going to find that, means, like, how we going to find that. So I just want to give a simple example. The probability of a spam given words. Okay, so we given a some sort of words, and then we simply give the spam given words. Okay, we going to find the spam in that given words. Okay, so we just simply do the probability of the words which are spam, words given spam, and into the probability of the spam, and then we're going to divide with the probability of that words. Then we're going to find these probability, like how much these are the spam and what are those words. So, and we just simply, based on that result, we just simply divide these spam and ham. So I just wanted to, so we going to have a great detailed talk in these projects, and also in the machine learning, like if we come these like spam and ham and etc. So we have a great detailed talk over there. So this is a basic intuition about all these distributions and etc. So I just wanted to recapitulate. So it is a, so first we have a uniform distribution, and after that we have a normal distribution, how we gonna that, and we have empirical rule that, and after that we have a geometric distributions, and we have a binomial distributions, and we have Bernoulli distributions, skewness, and a Bayes theorem. So I hope you love these lectures, this probability and statistics lecture. So these lectures are finished, and we are going to launch the machine learning lectures as soon as possible. We are making a full syllabus and in a structured way that covers the basics to the advanced level, and we are taking from guidance from the lot of smart people out there. So I hope you love those lectures also. So I just want you to please like this video and share with your friends. Okay, so I hope you love this lecture. Until then, bye bye, see you in the next lecture. see you in this machine learning full machine learning course. Okay, so introduction in the machine learning course. Until then, bye bye, see you in the next lecture.